Hello, welcome to Chapter 9, homework questions 83 through 88. 83, multiple choice. Which of the expressions below is a factor of 6x squared plus 7x minus 20? So to figure this out, we're just going to go ahead and factor it and then pick which one it matches up with. So we'll start out by using the generic rectangle. We get 6x squared and negative 20. We want to figure out what numbers are going to multiply to give us negative 120x squared and 7x. So we get a lot of factors of 120, but 1 and 20 and 2 and 60, those aren't going to work. Those are too far away. So let's see if we can get a little bit closer and see if we can find a number that's going to give us 7x when we add it. And it looks like 15x and negative 8x would add to give us 7x and multiply to give us a negative 120x squared. So we'll plug those into our generic rectangle and then pull out the factors to make the side link. So it looks like this would have to be a 3x, this one would have to be a 2x, which makes this a negative 4. 2x times negative 4 is negative 8x, and 3x times 5 is 15x, and then 5 times negative 4 does give us the negative 20 at the bottom. So it looks like this would factor to 2x plus 5 and 3x minus 4. So which one of those do we have? It looks like on A we have 3x minus 4, and just double check, 2x plus 5 is not there, so it looks like A is our correct answer. Question 84. Graph the inequalities below on the graph paper. We're going to graph problem A on the first graph and then problem B on the second one. So we'll start with A. We want to set the inequality up as an equation so we can graph the boundary line. This has a slope of negative 1 and a y-intercept of 0, 5. So we'll plot the point 0, 5, and then since your slope is negative 1, you need to go down 1 over 1 to the right or up 1 to the left 1. If you want to spread those out a little bit, you can go down 2, you can go down 3, but just make sure it still represents negative 1. So I'm going to go down 3 over 1, get a point again, go up 2 over 2. Just kind of get my point spread out a little bit. Is the boundary line solid or dashed? It is solid because it's equal to, so that will be part of the solution. So we want to graph the line as a solid line. And then now we need to test a point to see where we should shade. And we will test the point 0, 0 as long as it's not on the boundary line. And if we plug this in, we get 0 is less than or equal to negative 0 plus 5, or 0 is less than or equal to 5. And that is a true statement, which means this point is a solution. That's what we just found out. And so if it's a solution, then all those points on that side have to be solutions. So everything on the line and everything below the line will be solutions. So you shade below the line. All right, on B, we have y equals 2/3 x minus 1. We have a slope of 2/3 and a y-intercept of negative 1 here. So we'll plot that, and then we'll go up 2 and to the right 3. You can do that a couple of times. You can also go down 2 and to the left 3. And this one is not equal to, so we do want a dotted line on this one, indicating that the points on the line are not solutions. And then once again, we will test the point 0, 0 as long as it does not fall on the boundary line, and it does not. So is 0 greater than 2/3 times 0 is just going to cancel, negative 1. So is 0 greater than negative 1? Yes, that is true. So that means this point, once again, is a solution. So we want to shade on the side where that point is. So since this point is above the line, then we're going to shade everything above this line to indicate that's where our solutions are. Now on this one, we have a dotted line. So therefore, the solutions, or the points on the line, are not solutions. So only above the line is what would be considered a solution for this inequality. Question 85. Write and solve an inequality for this situation. To honor 50 years in business, All Strikes Bowling is having an anniversary sale. Shoes rent for $1.25, and each game is 75 cents. If Charlie has $20 and needs to rent shoes, how many games can he bowl? So before we write and solve an inequality, we do need to identify what it is that we don't know when we're solving for. So we're going to write a let statements. How many games can he bowl is the question. So we're going to let G equal the number of games bowled And to set this up, we kind of have to identify some other important pieces. So the shoes rent for $1.25. So that's a one-time fee. $1.25, that's all you have to pay one time. But each game is 75 cents. So to set up our math statement here, and we'll write it as an inequality as well, is we know that for each game, it's going to cost 75 cents. So 0.75 times the number of games plus this fixed amount of $1.25 per shoe rental, but only it's a one-time fee. And Charlie has $20, so he can only spend $20 or less. He can't spend any more than $20. So we're going to say it's less than or equal to 20. Now we can go ahead and solve the inequality by subtracting $1.25 to each side. And so that would be $18.75. And then we can divide by 0.75. And we get G, and really should be looking at this as an equation because we're trying to figure out that boundary point. And so G would be equal to 25. Now, how many games can he bowl? Well, it came out to be a nice number of 25. Remember, we do need to look at the inequality sign, is that he has to spend less than or equal to 20. So we can kind of think about this. We can also create a number line if we need to, and we can test a point. But if you think about the application side of it, 25 games is going to give you $20. That's how much it's going to cost. So if you go 26 games, then obviously that would cost more. So we're only looking at values that are less than or equal to 25. And really, we kind of have a boundary on the other side just because you're not going to bowl any less than 0 games. And so sometimes with applications, you can actually think about it instead of testing a point. And it makes sense that we're only talking up to 25 games that Charlie can bowl. So when you write your answer here, you don't want to say Charlie can bowl 25 games. He can bowl at most 25 games. Could bowl anything less than 25 as well. So we want to be clear on how we answer this question, is that he can bowl at most 25 games. And I guess one thing maybe I could add to this, because it does say right, and I did write the inequality right here, but also maybe to write it as a solution that G is less than or equal to 25. But in the end, really being able to answer the question is that important piece. Question 86. Solve the following equations and inequalities for x. Check your solutions if possible. So in part A, we have 3 divided by x is equal to 9, so this is an equation. We can multiply both sides by x, so we can get the x out of the denominator. So 3 divided by x times x would cancel it, and then 9 times x. So those cancel, and we're left with 3 equals 9x, divide by 9, and x is equal to 1/3. And then it does say check your solutions, so I went ahead and showed you the check as well. On the next one, part B, we have the square root of x is equal to 4. So with the square root, we can square both sides to cancel out the square root because they're inverses. So x is equal to 16, and we can do a quick check on that because the square root of 16 is 4. Alright, moving on to C. C is another equation, x squared equals 25. Because we have to take the square root of both sides, that actually gives us the absolute value of x. Because remember, when you square a number, you can square a positive and negative and get that same positive number back. So we do the absolute value so that we know that the two solutions will be x equals -5 and x equals 5. So our solutions, once again, are both -5 and 5. And we can check that by plugging both of those in. If I plug in -5 and I square it, we get 25. So that checks out. And if I plug in 5 and square it, we get 25 also. So there's the check for both of those. And then the last one, D, is an inequality. It's 2 times the quantity x minus 3, so I'm going to go ahead and distribute. We're going to set it as an equal sign, or an equation, so that we can find the boundary point. We add 6 to the other side, divide by 2. X is equal to 5, so remember we want to think about, what this is going to look like. It is greater than, so we do need to, there's no equal to sign, so it's just going to be an open circle. And then we need to test a point. We'll test 0. So 2 times the quantity 0 minus 3 is greater than 4. I'm going back to the original problem because that's where we want to see whether it's true or not. So 0 minus 3 is negative 3. And then is negative 6 greater than 4? And that is not a true statement. So therefore, 0 right here is not a solution. So that means the points to the right of 5 would be solutions, which would be all values of x that are greater than 5. And make sure you do the number line and the inequality for your solutions. Question 87. During a race, Bernie ran 9 meters every 4 seconds, while Wendell ran 2 meters every second and got a 9-meter head start. If the race was 70 meters long, did Bernie ever catch up with Wendell? If so, when? And then justify your answer. All right, we're looking at 2 different equations here. We're looking at Bernie. And Bernie ran 9 meters every 4 seconds. So that's the rate of change, which would represent our slope. We do need to define our variables. So y would represent the distance traveled, and x would represent the time. Distance is in meters, time is in seconds. And so if Bernie ran at 9 meters every 4 seconds, then Bernie would be y equals 9/4 times x. And Bernie started wherever he did it, the starting line, I guess. Whereas Wendell, though, ran 2 meters every second, so y equals 2 meters every second, and got a 9-meter head start, so that's plus 9. So Wendell got a head start from Bernie, so he's 9 meters ahead. If the race was 70 meters long, did Bernie ever catch up with Wendell? So our distance we now know. So we'll plug in 70 for Wendell. Solve for that. Subtract 9. 61 is equal to 2x divided by 2. And x is equal to 30.5. And that's in seconds. So that's how long it took Wendell to finish the race if they ran for 70 meters. Whereas Bernie, we have 70 is equal to 9/4 x plus 0. The plus 0 is not going to matter there, so let's kind of get rid of that. We'll multiply both sides by 4, and that'll be 280 is equal to 9x. Divide both sides by 9, and we get a value of x equaling 31. And it says 0.1 repeating, so that would be 31 and 1/9 seconds. So Wendell got the head start, finished in 30.5 seconds, and Bernie finished in 31, approximately 0.1 or 1/9 of a second. So the question was, did Bernie ever catch up with Wendell? And the answer to that would be no. Bernie did not catch up with Wendell. And so it says, if so, when? Well, Bernie never actually caught up to Wendell, so we don't necessarily know when, but we could find out if the race was a little bit longer. So let's go ahead and see if we can figure out when they would have caught up. So if we set their 2 equations equal to each other using the equal value method, that will allow us to find the x value when the distances are the same. So let's go ahead and see what we get when we do this. So 9/4 would be 2 1/4. So if you subtract that, that would minus 2 would give you just 1/4 x is equal to 9. Multiply by 4, and we get 36. So 36 seconds is how long it would take for Bernie to catch up, which if we plug that back in to see what that actual distance is, we would get y is equal to 81 meters. So just kind of maybe going a little bit further than the question asked, but if the race was 70 meters long, did Bernie ever catch up? No, Bernie did not catch up. And it says if so, but even though he didn't, we went ahead and found out that it would have taken 36 seconds to catch up, which would be a total of 81 meters. And so I kind of, once again, maybe a little bit more than what I needed to, but no, Bernie did not catch up. He would have needed 36 seconds and 81 meters to do so. Question 88. Determine the number of times the graph of y equals 5x squared plus 7x minus 6 intersects the x-axis using 2 different methods. The answers from each method should match. So we're trying to figure out the number of times it intersects, but also let's figure out, what they are as well. So we have y is equal to, which is 0, because we're going to solve this first by trying to use the zero product property. That's if it is factorable, so we'll figure that out in a second. 0 is equal to 5x squared plus 7x minus 6. So is this factorable? Let's go ahead and use our generic rectangle to see if we can do this. 5x squared minus 6 on the 1 tiles, and then we know that the product of each diagonal should be the same, so we know that it'll be negative 30x squared, and then our middle term we have a total of 7x tiles. So are there any factors of negative 30 that are going to add to give us 7? So it looks like we can use 10x and negative 3x. That would multiply to give us negative 30, but add to give us 7x. So let's plug those in and then figure out the length. This would be a 5x and this would be an x. That means this would have to be a plus 2 and then a minus 3, and then double check the negative 6, and it does work. So we have factors of 5x minus 3 and x plus 2. So it does factor, which means we can use the zero product property by setting our factors equal to 0. Once again, remember the zero product property states that if 2 or more numbers or quantities are being multiplied to give you 0, one of them must be 0. So we set both of them equal to 0 and solve for x. So if we add 3, divide by 5, and on the next one subtract 2, we get an answer of x equals negative 2 and 3/5. So that's one method. Another method we could do is using the graphing calculator by plugging that in. And using remember you'd press second calc and look to see where the zeros are. So that's a possibility. I can't really show you that on here though, so I'm going to choose a different method. I'm going to go ahead and choose the quadratic formula for my next one. I'm not going to do completing the square because I have a 5 right here, and I'd have to divide everything by 5, and that could get pretty messy. So we're going to use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we need to identify what a, b, and c are. A is the number of x squared terms, which is 5. B is the number of x terms, and that's 7. And c is your constant, which is negative 6. So we'll plug all that in and simplify and see what we get. So we have the opposite of 7, so that would be negative 7, plus or minus 7 squared minus 4 times 5 times negative 6, divided by 2 times 5. So you can just plug in everything in underneath the square root into your calculator and see what number you get. And we get 169, and if you don't know, that is a perfect square, so we can simplify that, and if not, you could have just plugged in the calculator to find out that it is 13. So we have negative 7 plus or minus 13 divided by 10, so we're going to set up two equations here, or two situations. So negative 7 minus 13 divided by 10, and then we also have to do the positive, negative 7 plus 13 divided by 10. So we get negative 20 divided by 10 is negative 2, and then 6 divided by 10, reduce that by a factor of 2, and that is 3/5. And if you look to what we did earlier with the zero product property, you notice that we have exactly the same answers, which is a good thing. Doesn't matter what method we use, we should always be able to get the same answers.